So I will start to present my project for Physics 100, and I'm Nicole. My Chinese name is Yi Yang, so I will start right now. First, the step 1 for my project is using the equations to do the calculations. So the calculations is divided into two parts. The first part is use these equations. This ones, I use t to calculate the h, which is distance. But according to the project, the units for these two t and h are different. The units for t is millisecond, and the units for h is millimeters, because the units are different with the one we used before in this equation, so we have to change it a little bit. So after I change the equation, it looks like this. So this equation is used for the units we use now, which is millisecond and millimeters. And the increment for the t is 10 millisecond. So I also put some examples here, which the t I use is from 0, 10, 20, 30, and etc. Until I collect enough data I need. So this is the first part of my calculations, which use t to calculate h distance. After I finish the data, I do a chart which looks like this. As the time's going, the increasing of the distance become bigger and bigger. So it's not a straight chart, it's a curve, which shows the distance, the increasing of the distance gets bigger and bigger. So the second part of my calculation is use the distance h to calculate the times t. So as well as the one we used before, because the units are different, which is millisecond and millimeters. So I also have to change the equation a little bit. The green one is the equation I used in the Excels, which is used for the units we use right now. And the increments for the distance is 5 millimeters. So the data I put in my Excel is from 0, 5, 10, 15. The interval for the distance is 5. So this is the second part of my calculations, which use distance h to calculate the times t. And after the calculations, I got a chart looks like this, which is also a curved line. So as the distance gets bigger and bigger, the reaction time, the increasing of the reaction time gets smaller and smaller. So it cannot be a straight line, it is a curved line. So after my two parts calculations, I go into step 2, which is put the data I get from the second calculations on the strip. So this is the picture of my finished strip. The interval of the distance is 5 millimeters, and the left side, the numbers I put here is the reaction times. So after I finish the strip, I use this strip to test people's reaction times. This is my step 3. So in my 20 projects, there are 5 men and 15 women, and in total 20 people, there are only 1 people who like to play basketball all times, and there's also 1 people who are going to bed. So after I collect all the data, I answer these questions. The first question is there any patterns in the reaction times? So the patterns I find is on the people who like to play, who who like to play the basketball, his reaction time is smaller, which is faster than anybody else. And men's reaction time is also faster than women's. And there's one people who are almost going to bed, and her reaction time is smaller, which is slower than the normal people. So the second question here is asking if the reaction time strip will be different on moves and on the Jupiter. So because in these two planets, the gravity changed. So I will talk about the moon first. Because on the moons, the gravity gets smaller. So our reaction time, according to the equations, our reaction time will get bigger. So which means for the same person, the reaction time will get slower because the numbers get bigger. So, but for Jupiter's, because the gravity is on Jupiter's is bigger than on the Earth, so since the gravity get bigger, according to the equations, the times will get smaller. So that means for the same person, the reaction time will get faster. So this person's reaction time is faster on Jupiter than on the Earth. So for the second questions, that for some people whose reaction time is greater than 2 seconds, that means the strip I use right now cannot calculate his reaction time really well, because this strip is not long enough. So I cannot calculate people with a long reaction time with this short strip. The method I can use is I can find a longer strip, or I can use another method, which is I can show him a picture in the computer, and he have to click the mouse, and I can calculate the time he used to click the mouse. That's another method. So the last question is for someone whose reaction time is extremely fast. So I don't think the strip I use right now can calculate can be suitable, because for the reaction time whose reaction time is less than 0.1 second, the interval is big, which is like 32, 45, 55. The interval is 10. So I cannot calculate his reaction time accurately. So a better method is I can make the distance smaller. The interval for distance is 5 millimeters right now, and I can change it to 2 millimeters or 3 millimeters, which if I put the smaller interval distance into equations, I will get the reaction times which is smaller. So that's one way to solve these problems. So that's all I have for my project. So thank you for your watching. And I also got besides the point, I also got my Excels here, and here it has all the data, 20 people's data here, and I also got their standard deviation and mean. So that's all for my project. Thank you for watching.